You are listening to Tech Nuggets and Thoughts podcast, the show that focuses on principles and practices of coding and some interesting trivia around technology. We discuss all those things that a developer needs to know to craft better software. Listen to Nikhil, Christian, Siddesh, Mandar talk about their experiences and learning, which will make you a better developer.
Welcome to the fourth episode of Tech Nuggets and Thoughts. From today, we are going to start a multi-episode series of podcasts about development practices grouped under a broad title of Delivering with Confidence. The first podcast in this series and today's topic of discussion is testing.
So what is testing? And maybe in simplest terms, testing is knowing that your code is working and when you deliver, nothing will break and it will behave as expected.
I think the behave part is very important because when it comes to verification, we have different types of verification. For example, we also have static code analysis, but typically static code analysis is more about the structure of code. Static code analysis will tell me about technical errors. It can tell not about behavioral errors. Right. Therefore, so testing is very much about behavior.
Right.
Yeah. And for me, a test is an executable specification of required behavior.
That's an interesting way of putting it. Yeah. Test is an executable way of
specification.
Yes.
Specification.
Right. So executable specification.
Which means you're also kind of linking it to the documentation.
Absolutely. The reason why I like this thought process of linking testing with documentation is, imagine your projects that you've already done in the past. At the end of the project, at this release ceremony that may take a few minutes or hours or weeks, depending on how sluggish your process is. What do people look at? Do they look at the requirements? Do they go through requirements and tick off all of them? Or do they look at the test reports?
Yeah. And even to convey what this particular software does, would you want to read through a few bundles of or pages of requirement documents, or would you rather see point-to-point statements that just describe what this piece of code does?
Another thing which I want to throw in, which is not directly about testing, but which is very useful to understand when we want to get testing right, is a new view on requirements. We call whatever the customer tells us, and we call whatever we write down for what the customer needs, we call that the requirements. But this is, to the actual requirements, the same as design is to the source code. It is a model and it is incomplete. The true requirements that we actually have to meet with software in a formal way are our tests. And that is why it totally makes sense that at the end of the project we don't read a requirements document, because that's just like some abstraction. It's incomplete, but instead we look at the test report.
Right. There's also a factor of maintaining those requirements. So if it's a completely separate document, then there are two independent processes. One to maintain that document and update the code and update the tests. If the tests are documents, then it's just coding and updating the test. That's it. So done as a single unit.
And that already leads us in the middle of behavior-driven development. Because that is what it's basically about. We describe the required behavior in a way that is specification and documentation and make that executable.
Yeah.
So where does that fit in with the test pyramid of testing, where the different stages of phases, levels of testing are discussed?
So in test pyramid, on the lower part we have unit test. Then in the middle part we have integration test, system test, and at the topmost part we have acceptance test. The pyramid actually resembles the volume of the test that code should have, which means that there should be a lot of unit test, a moderate amount of system and integration test and lowest possible acceptance test, and the reason being is the speed of execution. So it actually emphasizes anyways that the unit test should be fast.
I thought that since unit tests are specific, they automatically cover a smaller amount of piece of code, and so you have to write a lot of unit tests. Acceptance tests are higher view, or like they are kind of high above the code, or they are outside the components of the code, and that's why they have a larger view in one statement. And that's why the number of acceptances automatically reduces, and they cover a large amount of code automatically by the nature.
I think both views are right, and they're actually not really contradictory. There's something to add to this. When we look at requirements, we will find requirements where different parts of the same requirement are implemented in different layers of the system. And we find requirements where the entire logic is really just mapping down to one or two classes, which means sometimes I have functionality which I can really pin down on pieces of code. When we look at test coverage, we want that we cover as much as possible because we want to release with confidence. And for that we need coverage. When we try to obtain as much of the coverage as possible with acceptance tests, our tests are going to be slow. And one of the reasons why we want a test pyramid is for each test case that we want to cover, when all the permutations that we want to cover with our tests, we want to pick the fastest available technology. That's again something where I find a framework like Cucumber so interesting, because with Cucumber I separate test specification and test implementation. So I can have the same test specification and I can start writing that with an implementation that is on the acceptance test layer, and as I move on and I discover that my tests are getting slower and slower, I will say, okay, do I really have to test everything on the acceptance test layer? Yeah, and some things, well, of course, yes. Some things have to stay there, but certainly not everything. Let's say we develop a delivery service and I support UPS and DHL Blue Dart and 10 other delivery services. Do I have to acceptance test every single delivery service and their specialties? Probably not. Do I have to test them? Probably yes. So I want to test the wires for some of them from an acceptance test perspective, but the permutations should be pushed down the layers of the test pyramid so that my tests will run fast.
Right. There's another thing that I observed based on like looking at this test pyramid is the specificity of pinpointing problems that acceptance test versus unit tests have. So unit tests cover smaller percentage of code. They tend to be fast because they cover smaller percentage of code, and they're also very specific. So if a unit test fails, I know exactly most likely the class, most likely the method that has a deviation from specification. If an acceptance test fails, it can be anywhere in between the entire flow of code that was executed. So I think unit tests would tell us more specifically and more and faster if something breaks than acceptance tests.
Exactly.
Yeah. This line was supposed to be at the start of the podcast, but I want that people should know that the intended audience for this podcast is developers. I mean, I don't want that developers should, this is regarding testing. I don't want to do it. So, because I have seen that developers here are not that really serious about testing.
I just want to say that all testers must be developers. I mean, there's no testers that are not developers, and there are no developers that are not testers.
In an ideal world, yes. Definitely.
Yeah.
In an ideal world, yes. But when, you look for you have this job opportunities, or you see there are testers, and then they are segregated into like manual tester, automation tester. So I was like, okay, first of all, I'm not looking for a tester, and then why do I will go in the detail like, oh, you're a manual tester, okay, that is what I wanted. Like, why? So I don't want the developers just write this test for sake of writing it. Okay, I have written this. Let's take 2-3 behaviors and I'm done, and then the tester would take care of that. That is something. So that is the reason I wanted this line at the start, that whenever a developer listens to this, he should know that this is for him as well.
I fully agree with that. To add to those things, I think a lot of organizations have a wrong hiring strategy. They recruit people who they like, and they group them into 2 categories: a category that can code and a category that is not so good at coding. And those that can code become the programmers, and those that cannot code so well become the testers. That is exactly the opposite of what should be happening. Testers should be those developers who have so many skills that they know where the typical gaps and loopholes are, and that is requiring experience. The original idea of the tester profile in the 70s, when software engineering became a topic, was the most experienced developers will become the testers because they know from experience what can go wrong. And now we have something like manual tester. Manual tester is something that, in my opinion, violates the Geneva Conventions. It's how can you think of that as a job profile? You actively become professional in something that is automatable by a machine. You're competing with machines in something in which machines are better. When it comes to reproducing the same thing again reliably, that's not the strength of humans. The strength of humans is creativity, using our brains and our imagination.
I do consider manual testing as a niche job or a requirement. There are not all test cases or scenarios can be repeatable. The particular case of destructive testing, of like maybe just a random example as to just keep on doing forward and back on your website and see if it still remains valid, the page still remains valid, is a case that probably cannot be simulated, or just try out things that are not repeatable. But to break the software are things that are the cases where we need a real human creativity to be applied to break the software in ways that maybe repeatable methods cannot.
So probably just act random with the software.
Maybe.
Yeah.
I agree. That is what manual testing should be about. But that is not a repetitive activity. It should not be used for regression testing.
Yes.
It should be for specification, for finding gaps in requirements, and for test discovery.
Yes, I totally agree. So
And what about performance, speed?
I think that this can be automated. We have tools like JMeter, and if your program doesn't fit in the category that you can cater to with JMeter, you will still have other ways how to performance test.
Yeah. So this is for all the manual testers. You guys are important, very important. But we are just trying to tell you that step up. You need to educate yourself a bit more, because this is very competitive world, right? I mean, so this is for your own good.
and
we care for you. Yeah, we care.
And developers, you cannot leave the responsibility of verifying or certifying your code with others. It's your job.
Exactly. The job of a developer is to write code that works, and not to write code that doesn't work and then let others find why it doesn't work. That's not the job of a developer.
Exactly. And the fun part is that both of this, developers and testers, are part of a Scrum team, which is supposed to be a cross-functional.
And
We don't want to go there.
Yeah,
obviously. I want to. I think it's very important to also get the message out that organizations should not have separate test departments.
That is a very excellent topic, by the way, and I would like that we have a podcast for that.
Are you suggesting this to cut me off on the topic?
No.
I'll want to take the discussion completely onto a different tangent here. So what we are discussing is after you have got the specifications, how you people are dealing with the development of the software. But where do business people fit in? We do not understand the language of software world.
Yeah.
So we will tell you how we generally communicate with the world outside, and now we are relying on the ability of business analysts or the people who are taking a requirement or writing that requirement down and hoping for next 3 to 6 months that whatever we have told would come back to us as exactly. So do we have any role to play while the software is being developed, or we just have to wait until some release comes to us for evaluation?
Yeah. For that, you have to tune into the next podcast.
But I think now that the audience had the patience to listen to the question, we should at least cater a short answer. Without business, there is no software and there is no job for people in making software. That shows the importance of business. But also, without dealing properly with business, and that means working together jointly with business throughout the day, we will not deliver good products that really cater to business needs. What we do more than just coding. We actually try to deliver business solutions for business problems, for workflows that business have. These workflows change. We have to cater to that, which will be another important topic in the continuation of our current podcast. And we have to understand your requirements, and we also have to understand that we have to help you understand your requirements as business. Because you will describe something with your language, and even in your world, your language might not be as precise as you need to implement a workflow. The business is an important topic. You play a role, you should play a role daily. Developers should ask business daily if they are doing the right job. You should be involved in a regular feedback loop on a daily basis and on an iteration basis, like every 2 weeks or something like that. I prefer usually 1 week iterations, but those details are actually worth another separate podcast. It's an important question, too important to just cover it in a sidetrack.
Yeah. And just to add, actually, like Christian, you already mentioned, there's no software without business. So there's no point in writing code that does not deliver value. And value comes from business. There's nothing that we can do without it. To answer the question in a maybe a bit more specific way, there are tools that help business connect directly with executable specifications. So we will cover them probably as we go on in this discussion. There was one point that we talked about that during test pyramids discussion, that there's something called as a unit test. So what would we describe it as?
Unit tests are tests that are fast.
Okay.
Exactly.
Best definition.
That's also my preferred definition. Unit tests are tests that run fast. I think in the past we've overemphasized on the word unit, and when we talk about unit, we immediately think of a structural unit that has boundaries, and then we come and get to a problem. The problem is the following. So why are unit tests or tests in general so important for delivering with confidence? They tell us that our software is delivering the behavior required by business. So we want to run these tests every time we release. Or even better, we want to run these tests every time we make a change. What types of changes do we make? If we, in the simplest classification, we can say that 2 types of changes. Changes to behavior, to add functionality or to correct functionality, and changes to structure, in order to make sure that the structure of our software can cater to the behavior. And when we talk about unit as a box with boundaries, we talk about structure. But in the beginning we said tests are an executable specification of required behavior. We want to verify behavior with our tests and not structure. So we want to minimize the dependency of tests on structure. If we overdo unit testing with mocking and with isolation, it means when we change structure, we have to change the tests. And then our tests stop serving the purpose. Our tests should give us confidence and make us fast. If I have to change tests every time I do a refactoring, then tests slow me down. And also, how good is a safety net that I have to move along all the time while I'm changing my position?
Yeah, so which means that you are saying the test should also have refactoring.
That's yet another thing. I should be able to refactor tests, obviously, and I have to refactor tests. They are also important. I think tests are more important than the code, the production code, which is another topic.
Historically, or when we go out to learn unit testing, all tutorials talk about, let's consider a language, let's talk about Java. Okay, all tutorials talk about testing a class. When we talk about testing unit testing, they talk about testing a class. So we are stating that we would not consider a class as a unit. It may or may not be actually when we are talking about tests being fast. If the class suffices or suffices for the purpose of a complete functionality that we want to individually test, maybe we can consider the class as a unit.
Yes.
If the class depends on multiple other classes, maybe we have to treat them as a unit. But we're saying that one functionality should be treated as a unit and not the class.
Exactly. Functionality. Yeah, that's the key thing. So I think the units are those boundaries where structure and behavior meet, where structure exposes behavior. That is what we should have as units. And sometimes this can be a class in isolation, sometimes it can even be a single function, and sometimes it can be a group of classes collaborating together.
But then by this definition, what would integration tests mean?
I have units that work together, which I cannot test together with a normal unit test. For example, my front end and my back end. For these, I have very special integration interfaces, like a REST API, for example. And on that level is where I see integration testing.
So in a way, when we leave maybe the physical boundary of the system that we cannot test across?
Yes, and whatever that is, that's a matter of software architecture. And so a unit is, unit tested, and then different units together can form components. And then we have component tests. They can be unit tests, they can be integration tests. I think the lines are a bit blurred. And I like to see for whom is the test. That's so the test automation pyramid that we've mentioned is actually coming from a book called Succeeding with Agile from Mike Cohn, 2008. And just beginning of this year, Robert C. Martin has shared a series of tweets in which he has given new meaning to the 3 layers. Robert C. Martin says acceptance tests are by and for users. Integration tests are by and for architects. Unit tests are by and for developers.
Okay, actually that's a very nice way of putting it, because that covers that also indicates the coverage that each test gives.
Yes.
Yeah.
And whatever you as an architect in your system or as a group of developers decide what is relevant for architecture, that decides what is your integration tests. Because not everyone obviously is working with REST APIs. People do IoT and other things. They have different interfaces, or sometimes they have complex systems where a single program has 800,000 lines of code. Then you need to devise components and integration tests between those components within that program.
All right. On that note, let's conclude today's podcast. We'll continue this discussion in the next episode. This is Nikhil signing out.
This is Christian signing out.
This is Siddesh signing out.
This is Mandar signing out.